For Project 3, I was primarily concerned with looking into the JetHexa's path planning trajectory and obstacle avoidance. For the first point, I wanted to determine why the robot takes a curved path for goal points that should intuitively result in straight line movement. Using RViz, I was able to view the coordinate frames of the robot and its map. I gave the robot multiple goal points and observed the central frame of the robot while it navigated to those points. What I found was that the robot attempts to match its central frame orientation with that of the map's orientation in addition to trying to reach its goal point. To test if the robot could indeed move in a straight line, I placed a goal point directly in front of the map frame. Since the robot's central frame was already aligned with the map frame, it moves in a straight line as expected. So now I have an idea of why the robot behaves the way it does in terms of pathing. With that part of the project complete, I then moved on to obstacle avoidance. As a refresher, in Project 2, recall the robot would collide with obstacles placed in its path. Naturally, this isn't the most desirable behavior to have in the robot, so to fix it, a layered cost map was used. The cost map now uses 3 layers. The first layer is the static layer, which is basically just the map of the environment. The second layer is the obstacle layer, which allows the robot to mark and clear obstacles in its sensing range. Finally, we have the inflation layer, which allows the robot to account for its physical size. As the name suggests, each layer lies on top of one another, beginning with a static layer, advancing with the obstacle layer, and finally the inflation layer. With all 3 layers utilized, the robot is able to avoid obstacles as desired. A potential problem, however, could occur if an obstacle's inflated radius happens to overlap with the goal point. The robot could end up taking a lot longer to reach its goal point in the correct orientation, and in some cases it may not reach the point at all. Fine-tuning the inflation layer parameters could help mitigate this problem. Thank you for watching.